Okay. Okay, let's just get started then, because I have no idea what I'm saying. So it's been a long day. Pretty much haven't been able to speak properly all day. No, that's not necessarily true. Okay, maybe it is. But we're on Lucky 7, and so that's a good thing. So this is Unit 5, Day 7. 7. And this is a cool day, because this takes something that looks so difficult and so impossible and makes it sort of kind of fun and like impress. Like you can impress your friends with this. Okay. Only if you really have nerdy friends and you really want to impress them, you can impress them with this stuff. But I like this stuff. I think it's kind of cool. Like you look at a problem and you're like, what the heck? Because I hated fractions, and now you're going to make complex fractions? Seriously? Like fractions weren't complex enough, so you're going to make them more complex? Like by making complex fraction? Like what's after this? Uber complex fractions? Wow. Actually, that's true. Probably next year I'm going to tell Mrs. Coppola to call them uber complex fractions. Like what the uber complex fractions are these? But for now, we just have complex fractions. So let's get started. Well, hold on. There's a button on the bottom that says subscribe. If you're watching my videos, do me a favor, subscribe. I could use a few more subscribers. I'm hoping to get to 2,000 real soon. If you see the donate button and you want to donate, that'd be cool too. And if one of my commercials at the bottom, somewhere down here, I don't know, maybe it's over there. I think it's over there. Over that direction comes out and you're like, wow, I really would like to have whatever just showed up there. Click on it. If not, don't click on it. Just click the little X and let's get going. All right. Ready to rock and roll. Let's try complex fractions. Ooh, complex fractions. It sounds so exciting. I'm so excited. Okay. So here's how it works. It's actually not bad at all. It's a little funky, a little weird, but it's not bad. As long as you can find the lowest common denominator, you're in great shape. Some of you are like, I'm still not good at that. Okay, but you got to get better at it. So let's make sure we're all set. We're still recording. Okay, that's good. So let's take a look. 7, 4, and 2 are all my denominators. And yeah, you got to look at all of the denominators. And so I say, okay, my lowest common denominator. Now, generally what you want to do is pick the two biggest, 4 and 7. And the smallest number that 4 and 7 go into is 28. Not 14, 28. And 2 goes into 28, so that's my lowest common denominator. So what I'm going to do is, just like before, I'm going to put a 28 next to every single fraction. All right, and then I'm going to simplify. 7 goes into 28 4 times. So when I'm done, I should have one fraction left. Not 2, but 1. But that's not bad. So that's 4 plus 4 goes into 28 7 times. So, and then I multiply these. That just gives me 7. By the way, the 4 came from multiplying the 4 times the 1. And then 2 goes into 28 14 times. So I multiply these, and I get 14. So this gives me 11 over 14. I'm done. I'm telling you. Wasn't that cool? You're like, what? All that just turned out to be 11 14s? You don't believe me, do you? You're like, I don't believe you, Kraus. You're full of doo-doo. And if you say doo-doo, by the way, get your man card checked. Get your female card checked. Whatever. Nobody says doo-doo. So let's check this. 1/7 plus 1/4. So control division. And then control division. And then 1/7 plus control division. 1/4 all over control division 1/2. 11 14ths. You're like, well, if the calculator can do it, why do I have to do it, Mr. Mouse? I don't understand. Shut up. Crush you like a bug. Now, let's take a look. 4 denominators this time. 5, 6, 3, and 4. So I'm going to take the two biggest, which is 6 and 5, and I'm going to find out what is the lowest common multiple of 6 and 5. So the lowest common denominator of 6 and 5 would be 30. Does 3 go into 30? Yes. Does 4 go into 30? No. So guess what? It will be a multiple of this. So the next multiple of that is 60. And yes, 4 does go into that, 5 goes into that, 6 goes into it, and 3. So 60 is our lowest common denominator. So we're going to do 60, 60, 60, and 60. And now we'll simplify. 5 goes into 60 12 times. So this leaves me 12. Plus 6 goes into 60 10 times. 3 goes into 60 20 times. That's 20. And 4 goes into 60 15 times. Now, you may not have known that, but you can figure that out. Plus 15. So I've got 22 over 35. Done. Now, I could check that on a calculator to make sure, but why would I? I teach mathematics for a living. It's got to be right. Maybe. Was it next? Was my big fat head in the way? I hope not. All right, so now let's start talking. Let's start growing up a little bit. We're going to get real grown up real fast. So here's what we do. We say, okay, I look at the numbers. The lowest common denominator just between the numbers is 6. But they all have an x, so it's got to be 6x. So I put a 6x next to each one. And then I start to simplify. X cancels with this x. That leaves me 6. Plus 2 goes into 6 3 times, and the x's cancel. So that's 3. 3 goes into 6 twice, and the x's cancel. So that's over 4. So my answer is 9/4. That's it. That's all she wrote. No matter what you put in, it will be 9/4 as the answer. Is that really true? Here's a way to check that one. Like, that's one I'm like, that's weird. So I'm going to take any value of x, 3.45, and I'm going to stow that into x. Now, if this is true, I should get 9/4 out. So, control division, 1 over x plus 1 over 2x plus control division 1 over 2x all over 2 over 3x. Control division 2 over 3x. 2.25. Weird. I wonder what 9 divided by 4 is. 9 decimal divided by 4 equals 2.25. Oh yeah, catching. All right, kiddies, let's get moving. So let's look at my denominators again. Oh, here we go. Let's look at the denominators again. We've got a 2, an x, and an x squared. So my common denominator, my lowest common denominator is 2x squared. Whatever the minimum amount is, that's what we need. Or the maximum amount is. In this case, the maximum amount of x's was x squared. So I'm going to multiply everything by 2x squared. So we got a little bit more work, I think, on this one to do. So this x squared cancels with this x squared, gives me 2 plus. This x cancels with one of these x's, and it leaves me 4x. And this 2 cancels with this 2, and it leaves me 5x cubed. And I can factor out a 2 out of the numerator, but why would I? That's it. We're done. Oh, man, I keep putting that stuff in my head's way. All right. Lowest common denominator is... Let's see, this is over 1. So I look at the 4 denominators, x, xy, y, and 1. So my lowest common denominator, believe it or not, is just xy. 1x, 1y. So I'm going to put a 1x, 1y next to each one of these. Now the beauty of this is if I do it correctly, When I'm done, I should have no more fraction on top and fraction on bottom. I will have a top and bottom, but I won't have a complex fraction. I'll end up with just a simple fraction. I don't need that big of a line. So let's go. This x cancels with this x. It leaves me 3y. This xy cancels with this xy. It leaves me just 1. This y cancels with this y. It leaves me x. And nothing cancels here, plus 3xy. Now we've got a little bit of work to do here. It looks like we might have to do some checking. Now in the numerator, there's no GCF. I can't take anything out, so I just left with 3y plus 1. In the denominator, though, I can take out an x. And when I take out an x, I'm left with 1 plus 3y. And yes, we can continue. This cancels with this, and it leaves me 1 over x. Now notice the x is in the denominator, so it has to stay in the denominator. There's my answer. All right, put this over 1. Looking at all my denominators, 1, 2, and x. My lowest common denominator is 2x. So I'm going to put a 2x next to every one, all of them. Even this one down here that didn't start with a denominator, I'm still going to do it. Because if you don't, it doesn't make any sense. Now, someone's saying, well, how am I not changing the value? And that's a great question. That's a great question. So let me address that. Let me address that right now. So here's what I'm going to do. What I am in effect doing is this. Let me look at this problem again. We've got 1/2 minus 1 over x all over 3 over 1. So what I'm actually doing is I'm multiplying everything by 2x. So I'm going to multiply this top by 2x and this bottom by 2x. Well, if I multiply the top and bottom by the same thing, isn't this just 1? Sure. Yes, Mr. Krause, just 1. And what I'm going to do is I'm going to multiply this by 2x and this by 2x. So this gets 2x and this gets 2x. And I multiply this by 2x. So it looks like I'm not multiplying by 1, but I really am. I'm really just multiplying by 1. And what I'm doing is multiplying everything through by it. And if you don't multiply the denominator by 2x, then you're changing the value. You're not multiplying by 1 anymore. You're really just multiplying by 2x. So you got to get comfortable with that. All right, so having said that, these 2's cancel. I'm left with x. These x's cancel. I'm left with minus 2. Nothing cancels here, so it's all over 6x. And that's my answer. Done. All right, it's going to start getting more complicated. Well, maybe. Let's look. 3w, w, 3. All right, so our common denominator clearly is 3w. So we're going to multiply this by 3w, 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 3w. Alert! Alert! I just noticed something. Alert! Alert! We got a minus in the middle. Change that to a minus. Change this to a -1. Otherwise, you're going to mess it up. More than likely. All right, so 3's cancel. And I'm left with 7w. The w's cancel. Plus 3. All over. The w's cancel. 6. The 3's cancel. Minus w. That's it. Wow, that was simple. So I can't simplify it anymore. All right, what does the negative exponent rule mean? So let's remind ourselves. If I've got x to the -1, really that's equal to 1 over x. Do you remember that? Have we addressed this before? Yeah, we've said that negative exponents have nothing to do with being negative. What if I have x to the -2? Well, that's equal to 1 over x squared. What if I have x to the -1 over x to the -2? Well, I can rewrite that if I wanted to as 1 over x times 1 over x squared, because that's what that is, and that's what that is. And then you multiply by the reciprocal, so I multiply by x squared over 1, and I end up with just x. Weird. So we're going to play around with that idea. So I said here, rewrite using only positive exponents. So this one's really easy. It's 1 over a. That's it. Now, this one, I can simply just move these up here. But I want to show you something a little bit different. This is 1 over a squared. So what this really is it's 1 divided by 1 over a squared. Or another way to write this is 1 over 1 divided by 1 over a squared. And you guys remember, when you divide, you multiply by the reciprocal, right? So really this is 1 over 1 times a squared over 1, which is just a squared. And we just said a couple of minutes ago, I could move these to the top and just make them positive. So I'm not going to do that. I'm going, because you'll see why in a minute. Things start getting a little funky, a little crazy, a little crazier. What this is 1 over a divided by 1 over a squared. Now, if you have division, you can just take this, bring it up here, and flip and multiply. So we're going to multiply by a squared over 1. Well, what I end up with is a squared over a, which is really just equal to a. And actually, that turns out to be the problem I just did right up there. Now, having said that, let's take a look and see the way we would have done it last week. And I'll show you why I'm doing this way in a minute. But what I could have done is just take these and move them up here, and take these and move them down here. And that only works if you have all or adding and subtracting, or just plain monomials like that. So I could have brought the a squared and a to the negative 2, brought it up, make it a squared, make the a to the negative 1, bring it to the bottom, bring a, and then divide, and I get a. Now, there's a reason I'm not doing that. Now, I'll show you in a second. This is 3 minus 1 over a cubed. Now, what did I say? What are my directions? Rewrite with a positive exponents only. I want to combine these, though. I want to write it as one fraction. So in order to write this as one fraction, I need to have a common denominator. In this case, the common denominator would be a cubed. So this would be 3a cubed minus 1 all over a cubed. All right. Now, here's where you have to be very, very careful. This is read as 4 times a to the negative 1. So this is the only thing that's being raised to the negative exponent. So what I really have here is a fraction. So what I really have here is this over 1, right? This has to go to the denominator and become a. So this is 4 over a minus. Now remember, this is over 1. This goes to the denominator. 1 over a squared. Now the common denominator here is a squared. So I'm going to multiply this by a and this by a. So I get 4a squared over a squared minus 1 over a squared. So my final answer is 4a squared minus 1 over a squared. Now it's going to get crazy. Let's see how we're going to rewrite this one. Watch this. Now this whole thing is in parentheses being raised to the negative 1. So this becomes 1 over 5a. I didn't give you enough examples on this stuff. Well, 1 over 5a. And then the denominator is 3 minus 1 over a squared. Now we got a complex fraction. Now take a look. I got a 1, I got an a squared, and I got a 5a. What is my lowest common denominator? My lowest common denominator is 5a squared. Remember, number and whatever the highest degree exponent is. In this case, it's a squared. So I'm going to put a 5a squared here. a 5a squared here, and a 5a squared here. So this 5 cancels, and one of these a's cancel. That leaves me a in the numerator. This is just 15a squared minus 5. No, this is an a in the numerator. It doesn't look like an a in the numerator, but it's just an a. So there's my answer. Now I could take a 5 out of the denominator, so I could have a 5, 3a minus 1, but nothing cancels still. So either way it would be okay. All right, now let's talk about some crazy stuff. Oh no, this one's not bad. Put this over 1. Put this over 1. My common denominator, my lowest common denominator is x. So, this one requires a little bit of work. So I'm going to multiply everything by x. X, 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 and x. So here, nothing cancels, so I'm left with x squared. Cancels. Here, the x's cancel, so I'm left with minus 1. Here, nothing cancels, 2x. And here, the x's cancel, so minus 2. Now, the numerator can be factored and the denominator can be factored. The numerator is x plus 1, x minus 1. And the denominator, I take out a 2 and I'm left with x minus 1. So these cancel, and there's my answer. X plus 1 over 2. All righty, now we come to this challenge problem. If you can do this one, you're a boss. So this becomes 4 over 1 minus 1 over a squared. Remember, this is just thinking about this. It goes in the denominator of its own fraction. All over. Now, the only thing being raised to the negative exponent is this. So this becomes 2 over a minus 1 over a squared. You know how many kids would just try to cancel these two things out? No, 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 no. Don't forget, these things are in parentheses. All right, so let's take a look at the denominators. I got a 1, I got an a squared. I got an a, and I got an a squared. So my common denominator, my lowest common denominator in this case is a squared. So I'm going to multiply everything through by a squared. A squared, a squared, a squared, and a squared. Here, nothing cancels. I'm left with 4a squared. Here, the a squareds cancel. I'm left with minus 1. All over. Don't forget that's in parentheses. Here, 1a cancels, and I'm left with 2a. A squareds cancel, minus 1. So the numerator actually can be factored to 2a plus 1, 2a minus 1, because it's the difference of perfect squares, all over the denominator, which is 2a minus 1. And I do my final canceling. This cancels with this, and I end up with 2a plus 1. The really cool thing about all of these is you should know whether or not at the end of the day you got the right answer or not. So here was my original problem. Let me highlight my original problem in yellow. Now I'm going to go over to my calculator. I'm going to pick any value for a. 3.26, control var a. Then I'm going to do fraction, control division. And it is 4 minus a to the negative 2. 4 minus a raised to the negative 2 all over 2a to the negative 1, so 2 times a raised to the negative 1 minus a raised to the negative 2. So, hit enter, 7.52. And we said the answer was 2a plus 1. So 2a plus 1. 7.52. You should always know if you have the right answer, because whatever you can, don't use 1 or 0 or 2. Use a weird number. Use a weird number, because you know sometimes if you use a regular number, sometimes it'll work out, and that's kind of weird. But if you use something weird like 3.26 and check it, they should come out to be the same, and you should know whether or not you got it right. Complex fractions. All you got to do is multiply everything through by the common denominator. Oh, they're going to get worse. But not today. Rock on, kids. Nice job. That's it. Hit the subscribe button. Hit the like button. If you like the ads that came up and they shoot your fancy, that's great. There's a donate button some on there. I could use a little bit of donation. Still need a new computer. Today it didn't work too bad. All right, kids. It's been fun and it's been real. But you know, it has not been real fun. I'm just kidding.